Alrighty, so for today what we are going to be doing is we're going to be factoring trinomials in the form of x squared plus bx plus c, and you need to understand that the coefficient of the x squared term is going to be a 1. So before we start factor, let's talk about this next couple of problems. We're looking for you to find two numbers that do the following. The first one says they want you to find two numbers that are going to multiply to be a 5. At the same time, those numbers will add to be a 6. And the fact that they multiply to a positive number, it means both signs have to be either positive or negative. But the fact that they add to a positive, both signs have to be positive. So what two positive numbers multiply to a 5 and at the same time add to a 6? In this case, it should be 5 and 1. And there you go. 5 times 1 is 5. 5 plus 1 is 6. The next one is looking for you to find two numbers that multiply to a negative 6. But at the same time they add to a negative 1. In this case, we're now multiplying to a negative value, so the signs have to be different, one positive, one negative. The fact that they add to a negative number, then the bigger of those two numbers better be negative. So numbers that multiply to 6 are 5 and 1 and 3 and 2, but it's 3 and 2 that you're going to want to use, and you want the negative 3 and the positive 2 because that multiplies to a negative 6. A negative 3 plus a 2 adds to a negative 1. The next little puzzle. So this next one wants you to find two numbers that multiply to a 2 and add to a negative 3. Well, it's multiplying to a positive, which means the signs are the same. It's adding to a negative, so both of those same signs better be negative. So the only way to multiply to a 2 would be a 1 and a 2. In this case, it's negative 1 times negative 2, that's 2, and negative 1 plus negative 2, that's negative 3. The last little puzzle here is what we're going to try to multiply to equal negative 5. We're going to add to equal a positive 4. Again, it's multiplying to a negative. The signs have to be different. When you do the addition of those different signs, the bigger one should be positive because the answer is positive. So what two numbers will do this? It would be a 5 and a negative 1 because that multiplies to a negative 5, and 5 plus negative 1 add to 4. This is basically the game that you play when you factor trinomials. You're going to want to find two numbers that multiply to the coefficient of the last term, and at the same time, they're going to add to the coefficient of the middle term. You've got to be really careful about your signs. Well, what we happen to call these types of factoring problems, these trinomials, is we call them I am. So again, your setup looks like this: x squared plus bx plus c. And if we called these things I am, that's the I, that's the A, that's the M. The I stands for the Roman numeral of a 1. These are all 1x squareds. Well, the A stands for adding. You're going to add to whatever number is attached to that middle term, and the M stands for multiply. You're going to multiply to whatever that number is that's the last term. So here's how you're going to do this. Most likely you're going to start writing I am either on top or underneath your problem. And then you're going to do the game that we just played. I'll put with the addition part first. I want two numbers that add to 14, because that's where the A is. I want two numbers that multiply to 45. Well, it multiplies to a positive, signs are the same. It adds to a positive, both same signs better be positive. And hopefully you realize that 9 times 5 is 45, and 9 plus 5 is 14. So we found those two numbers. All that's left to do is just factor. And when you factor trinomials, you're looking to have two parentheses. Well, we know what the numbers are going to be. They're going to be positive 9 and positive 5. We've got to figure out what goes in the front part of the parentheses. And that basically says, how do we take this x squared term and break it up evenly? And the only way to do that is to have an x in the first part of each parenthesis. What gets filled in the last part of the parenthesis are those two numbers that you found to work. One of them was a positive 9, the other one was a positive 5. That order does not matter. So factored form of the original trinomial is this particular product of binomials. In order to check that your answer is correct, all you do is FOIL back. So you can check answer by FOIL. And if you get what you started out with as the original trinomial, you are correct. We'll do a check for this one, but not for the others. So if I check my answer, front times front is x squared. Outside, outside is plus 5x. Inside, inside is plus 9x. Last times last is plus 45. And this, in fact, does become x squared plus 14x plus 45. That was my original trinomial. So the answer happens to be these two binomials. And that's how you would write it. Okay. Let's try this next one. X squared minus 9x plus 20. Again, I need to I am it, which means I have to add to equal a negative 9. I have to multiply to be a 20. Well, the fact that I multiply to a positive, my signs are the same. The fact that you add to a negative, both same signs better be negative. So negative 5 and negative 4 will add to a negative 5 and will multiply to a positive 20. Again, all that's left to do is give yourself two parentheses. The only way that you can start these parentheses off with a 1x squared is to put the x's in the front here for both parentheses. So I've got x, I knew that was going to happen. Try this again. I'm going to have an x with the negative 5 and an x with the negative 4. Those, or I guess those two parentheses, that's the answer to this IM problem, to this factoring problem. Let's try it again. I have to add to the middle value and multiply to the last value. So I need to think about two numbers. And I'm going to write it a little bit differently. They're going to add to equal negative 2. They're going to multiply, I'm using the symbols now, to equal negative 63. Well, if I think about those two numbers that do that, the numbers will be a negative 9 and a positive 7. Those are the two numbers that add to negative 2 and multiply to negative 63. Just a different way to show your work. I don't care how you do it. But bottom line, you come down to your two parentheses, and one is going to be an x with a minus 9. One is going to be an x with a positive 7. And there's your answer for 3. On 4, I have to add to a 4. I have to add to a 4. I have to multiply to a negative 21. Multiplies to a negative, signs are different. The numbers that are going to do that would be positive 7 and negative 3. Almost got the sign issue there, so be careful with your signs. Very easy to mess these up. So then my final answer becomes parenthesis with an x plus 7 and a parenthesis with an x minus 3. Again, feel free to FOIL these out to check your answers, but if you're doing this work on the side, you should be fine. What's going to be different here now is you see that you've got x squareds and y squareds. Don't let that bother you. You still have to do the I am. So what's going to happen is now you're going to be adding to negative 15 and you're going to be multiplying to positive 50. The two numbers that do this are negative 5 and negative 10. So you started off the way that you normally would. You've got an x minus 5 and then you've got an x minus 10. But what's different is the fact that you've got this y squared on the end, you have to split that y evenly on the end. So you're going to be putting in a y on the back of those values that you found. This is the right answer. I will show the check on here because it's worthwhile showing you where the xy comes from. So if I were to FOIL this out, front times front is x squared. Outside times outside is negative 10xy. Inside inside is negative 5xy. Last times last is plus 50y squared. When you combine like terms, you do in fact get the original trinomial, which is x squared minus 15xy plus 50y squared. So don't let the variables on the end fool you. Let's try this guy. Here I have to add to a negative 7. I have to multiply to a negative 30. If I think about the numbers that do that, it's going to be a negative 10 and a positive 3. So my parentheses will be x minus 10y and x plus 3y. Again, the y's have to go on the end because you do have that y squared on the end and the xy term in the middle. So if we combine now these factoring, these IAMs with GCF, that's what you're going to see here. It's called factor completely. Completely basically means you're going to have to look for all the possible ways to factor, which means you're going to start factoring by GCF. And then you're going to factor by IAM. It's a two-step process. So if you look at number 7, the GCF up here is going to be a 3. When you factor by GCF, the 3 comes outside of an open parenthesis. What's left in here is x squared minus x minus 12. And then you need to IAM what's inside here. Remember, you're looking for two numbers that add to -1 that multiply to -12. So what happens is when you IAM in there, you're going to get x minus 4, x plus 3, but you cannot leave off the GCF from the very beginning. So answers for factor completely are going to be GCFs outside a poly in here. Really, it's a binomial, but a poly and a poly. So that's how your answer is going to look. Let's take a look at the last example. GCF here is a 2, which opens up outside of x squared plus 11x plus 10. Inside the parentheses, I've got to add to 10, but add to 11, but multiply to 10, and that's going to be positive 10 and positive 1. But I can't forget that that GCF comes down as a part of my final answer. So now we're combining GCFs as well as IMs. All right, so this should be good. You should be all set for the homework.